Hello students, welcome to Engineers Academy. Do hit the subscribe button if you are here for the first time. Now we are going to solve this particular problem by using one another method, and that is method 2. We have already solved this problem, and I will give the link of that first method in the description of this particular video. So the problem is again cable AB 6 feet long and the tension in the cable is 3900 pound. Determine the x, y and z components of the force exerted by the cable on the anchor B. Also find the angles theta x, theta y and theta z defining the direction of that force or tension in cable AB. So we are given this system or diagram, and this pole is supported by these three cables, and we are asked to find the components of the tension by this cable AB, and the components, we need to find the components at this particular point B. So in order to have the clear picture of this AB, I have erased this AC rope from this particular diagram, and we are going to consider this AB rope. So in order to find the components of the tension in this AB rope or the force in this AB cable, we need to cut this rope here. So let me delete this one. So we need to cut the rope here. Let's say if I cut the rope, so we will be able to see the tension in this AB rope like this. So this is that particular force or tension. Let's say that this is tension, and the magnitude of this tension is given, which is 3900 pounds. Now let me draw the x, y and z axes at point B. So this is our positive x, this is positive z, and this is positive y. Now we are given that this OB is making 20 degree with the positive x-axis, and we are given the length of this cable AB, which is 65 feet, and we are given the height of the pole, which is 56 feet. So now as we can see that this OB line is lying on the floor, that is in the XZ plane, and this pole is vertical, right? This pole is in the Y direction. So this means that this OB line and the pole is making 90 degree with each other. So if we consider this AOB triangle, this is a right angle triangle, and we are given this AO length, we are given this AB length. So by using the Pythagoras theorem, we can find this OB length. So let me find the OB length, and so this will be the hypotenuse, and this will be the perpendicular, and this will be the base. So we can say that AO is the base, AB is the hypotenuse, and OB is perpendicular. So now we can say that AB square is equal to AO square plus OB square, and we want to find OB. So OB square is equal to AB square minus AO square, and if we want to find OB, we need to take the square root. So OB length is equal to AB square, so AB is 65, the length of the cable, and AO is the height of the pole, which is 56. So 56 square, 65 square minus 56 square, this gives us 33. So 33, and this will be in feet, since the length of the cable and the height of the pole is given in feet. So this means that this OB is 33 feet. Now let's say that this AB rope is making angle theta y with the y-axis. So the angle of this AB with the y-axis is theta y. So we can say that this angle is theta y, or we can say that this angle is theta y, since this is parallel to this, and both of these angles are alternate angles. So we can say that this is theta y or this is theta y. So we can find theta y by applying the cos of theta y to this right angle triangle, this AOB triangle. Theta y will be equal to the base. So this is the base and this is the hypotenuse. So the base is 56 and the hypotenuse is 65. So theta y is equal to cos inverse 56 divided by 65. So cos inverse 56 divided by 65, this gives us 30.51. Theta y is equal to 30.51 degrees. Now once we have find OB, we can find the position vector that will or we can find the unit vector that will define the direction of this tension along this AB cable. So we can say that the T vector, the tension in cable AB vector is equal to T magnitude times the unit vector, and let's say this is the unit vector and this unit vector will be from A to B. And we can say that the unit vector from A to B is equal to the position vector from A to B divided by the magnitude of the position vector. So what is position vector? Position vector is a vector that tells us the position of a particular point relative to another point. So the position vector from A to B will tell us the position of point A relative to point B. So we can say that AB position vector will be equal to dxi plus dyj plus dzk. Now what is dx? The distance between point A and B in the x direction, parallel to the x axis. And dy is the distance between point A and B parallel to the y axis. Or we can say that the separation between point A and B along the y axis. And similarly, dz is the separation or the distance between the point A and B along the z axis. So now if we look into this whole diagram from the top, so let me draw that diagram here. So this will be our x-axis, this will be our z-axis, and here we will have O, and point A is on the top of this. So the point A and O, they coincide from the top. If we look from the top, then we will have that point A here. And somewhere here is our point B. Let's say this somewhere here is my point B, and this is our OB projection, and this OB is making 20 degree, that is given, that is 20 degree. This particular point is B, and this is OB. So let me write that this particular point is just B. So now the separation between point B and A along the x is this distance, like this. This will be our dx, and the separation between point B and A along the z-axis is this. So this is our dz. Similarly, we can say that if we look from the top, then point A and O coincide with each other, and the distance between point B and A is this along the z-axis. This is our dz. This will be our dx, and then this will be our dy. So this will tell us the position of A from point B. So the position vector from A to B will be dx, dy, and dz. Now this is very simple. We need to start from B, and we need to reach that point A, and we need to travel along these three axes and in any order. Let's say first, if I start from B, we need to move along the z-axis. So we have traveled this distance along the z-axis, so this will become dz. Then from here we will travel this distance, so we traveled a distance along the x-axis, but we have traveled in the negative x direction. This is the positive x, we have traveled this, so this will become minus dx. So first we have traveled this, then traveled this, and then we will travel in the positive y, so this will become dy. So now we will write the position vector from A to B. So the position vector from A to B can be written as, so first we will start from B, and so we will travel this distance. So this distance will be the sine component of this OB. We need to consider this right angle triangle. We know the length of OB. So OB is 33 and this is 20 degrees. So this will be the sine component. So 33 sine of 20 degrees is the distance traveled from B in the z direction towards point A. So we can say that dz is, this is dz, and dz is, we can write it here, dz is 33 sine of 20 degrees, and this is in the positive z direction, this is in the positive z. Then once we reach here, then we need to travel this distance in the negative x, and this distance will be OB cos of 20, and that is in the negative x. So I will write OB is 33, so 33 cos of 20 degrees in the negative I. So this is negative 33 cos of 20. And then once we reach here, then we need to travel this distance and this distance in the positive y, and that is 56 feet. That is given directly. So we'll write that plus 56j. So this is minus 33 cos of 20 plus 56j 33 sine of 20. So this is the position vector from A to B. And similarly, the magnitude of AB is the length of the cable, right? So that is 65. If we again take the squares of these components of AB and then take the square root by using the Pythagoras theorem, we will get that same 65 feet length. So let's do it. If I take the square root of the squares of the components of this position vector AB, plus 56 square plus 33 sine of 20 square, we get that same 65 feet. So this is 65 feet. Now this is the position vector. This I component tells us that point A is at a distance of 33 cos of 20 along the x-axis in the negative direction. So this means that this cable is pointing towards the negative x direction, or we can say that point B is away from point A is away from point B along the x, but in the negative direction. So, and then 56 feet and then this, right? And the direct distance between point A and B is the magnitude of the position vector. So the direct distance of point A from point B, or we can say that the direct separation of point A from B will be the length of the rope, right? That is obvious. This is 65 feet. So now we know the position vector, and so the unit vector is the position vector divided by the magnitude of the position vector. Now we can say that the unit vector from A to B, which tells us, the unit vector always tells us the direction. So now we can say that the position vector is minus 33 cos of 20 plus 56j plus 33 sine of 20k divided by 65. And similarly, if I divide all the components of AB by 65, this divided by 65, so minus 33 cos of 20 divided by 65, this gives us minus 0.477 I So now this is the unit vector from B to A, right? This is the position vector from B to A. This is not AB, this is the position vector from B to A, right? Let me correct this. This is the position vector from B to A. Now the unit vector always tells us the direction of any given force. So this is the unit vector of the force that is applied by this cable at point B. Now we know that the component of the unit vector can be written in terms of the direction angles. So we can say that the unit vector in terms of theta x, theta y, and theta z is always cos of theta x I plus cos of theta y j plus cos of theta z k. And these theta x, theta y, and theta z, they define the direction of a given vector. And these theta x, theta y, and theta z, these angles are known as the direction angles. And these components of the unit vector are known as the direction cosines. So we can say that by comparing this and this, we can say that cos of theta x is equal to this, cos of theta y is equal to this, and cos of theta z is equal to this. So now we can say that cos of theta x is equal to minus 0.477 and cos of theta y is 0.862 and cos of theta z is 0.173. And similarly, we can say that theta x is equal to cos inverse of 0.862, 0.173. So this will give us theta x, theta y, and theta z. We know theta y already. Theta y is 30.51, and this must give us 30.51 degrees as well. So first, let's find this 30.45, which is approximately 30.5, right? This is, if we take it 0.861, so then this is 30.57, which is approximately equal to that theta y. So theta y is equal to 30.51. Cos inverse of minus 33 cos of 20 divided by 65. So that is 118.49. So theta x is 118.49 degrees, and similarly theta z will be equal to, so theta z is cos inverse of 33 sine of 20 divided by 65. So this gives me 80. So theta z is 80 degrees. So theta x is 118.49, theta y is 30.51 degrees, and theta z is 80 degrees. Now once we know the unit vector from B to A, we can find the components, and we know that t vector will be equal to t magnitude times the unit vector. So now once we if we know the magnitude of t, we need to multiply that magnitude with these components of the unit vector, then we will be able to find the components of the tension T or the force in that particular cable at point B. So now we can say that T vector is equal to, this T vector is equal to the magnitude of the tension is given, that is 3900 pounds. So 3900 multiplied by this unit vector from B to A. So 3900 multiplied by the unit vector, which is this. Let me copy this. So this is our unit vector. So this is equal to, now the x component will be 3900 multiplied by minus 33 cos of 20 divided by 65. So that is equal to minus 1860 0.59, or we can say that, let's say this is 1860 I, then we have 3900 into 56 divided by 65, so 56, this is plus 3360J, and then we have 33 sine of 20 divided by 65, so that gives us 677K. So this is the component of that tension along the negative x. The magnitude is 1860, and the negative sign tells us that the component must be acting in the negative x. The y component is acting in the positive j, that is in the positive y, and the z component is acting in the positive z direction, that is in the positive k. So now we have, this will be tx component, ty, and tz. So the x component is in the negative x. So the tx is like this, tz is like this, and ty is like this. Ty is like this. So this is the solution of this particular problem. I hope this will help you in your learning. I will suggest you people that you guys must compare this method 2 with the method 1, and the link for the method 1 is given in the description of this particular video, and that will help you to solve such kind of problems using 2 different methods.